This video is going to serve as an introduction to quadratic functions, which is the topic of Unit 11. So first thing we need to know is what is a quadratic function. A quadratic function is a function that can be written in the form y equals ax squared plus bx plus c. This should look familiar to you, as this is just a trinomial in standard form. And this, in fact, is called standard form for a quadratic function. Do you remember the standard form for a linear function? If you do, go ahead and write it down. Standard form for a linear function is ax plus by equals c. You can see that there are some similarities between the two standard forms. They both contain x's and y's. They both have a, b, and c in them. The main difference between a quadratic function and a linear function is the exponent. A quadratic function has to have a power of 2. In fact, that's the highest power it can have. So if x has an exponent of 2, and that's the highest power it has, we're going to have a quadratic function. When we had an x here, this has a power of just 1. So a linear equation will have x to the power of 1. A quadratic will have x to the power of 2. What does a quadratic function look like? The simplest quadratic function we can talk about is just y equals x squared. It's the simplest possible quadratic, where if we're thinking about standard form, a is equal to 1, b is equal to 0, and c is equal to 0 in this quadratic equation. This is the simplest quadratic we can have. If a were equal to 0, then the whole thing would be equal to 0, and we would not have a power of 2. And we must have that in order to have a quadratic equation. So we're going to graph this quadratic by making a table. So I'm going to choose values for x, figure out the value for y, and then graph it on my graph. So the first number I'm going to pick is 0. That's always easy. 0 times 0, or 0 squared, is just 0. If I pick 1, I'll plug in 1 for x. 1 squared is 1. If I pick 2, 2 squared is 4. I could pick 3, but that would give me a y value of 9, and I can see that my graph doesn't go up to 9. So my only alternative then is to go into the negatives. So I'm going to pick negative 1. Negative 1 squared is also positive 1. Negative 2 squared is also positive 4. Now if I plot that, I have 0, 0, 1, 1, 2, 4. Negative 1, 1, negative 2, 4. If I connect the dots, this is the shape that I will find when I graph a quadratic equation. You'll notice it's not linear. It's not a linear equation or a linear function. It is a quadratic function, which will create a curve shape. Okay, for the next section, you're going to need your graphing calculator. What you're going to do is graph these 5 examples of quadratics in your graphing calculator. After you've graphed them, I want you to write down 2 things you observe about these equations and or their graphs. So just 2 observations that you have about the equations or their graphs. I'm going to pause, and you should pause your video too while you do this. One of the things that you may have observed about the quadratics that you just graphed is that they always create a similar type of shape. This shape is called a parabola. It can be like this, a sort of a U shape, or it can be an upside down U. It can actually be going the other way as well, as you saw when you graphed your examples. There's some special pieces of this that we may need to be talking about. One of them is the point at the bottom, in this case, or the minimum point of this parabola, that's called the vertex. Also, a parabola is symmetric, so this imaginary vertical line through the vertex is called the axis of symmetry. Everything to one side of this axis of symmetry will be the same on the other side. We saw that when we graphed the first one that we graphed. Okay, so one of the critical things we're going to be doing with quadratics is looking for their zeros. So, as we recently reviewed, a zero of a function is when the output value is 0. That means the y value is 0. So we're looking for points that have a y value of 0. As we've discussed in class, that means that those points will be along the x-axis, since all the points with a y value of 0 are on the x-axis. So the zeros of this first graph are at 3 and -3. Sorry, I should have said -3 and 3. This other graph also has two zeros at 1 and 3. Remember, zeros are the same as x-intercepts. So we're looking for where we cross the x-axis. Now, your calculator can also find the zeros of a function. This is something that will be important for us to know how to do. So we're going to take some time to do that together. So we're going to use the function y equals x squared minus 5x minus 6 and follow these directions to find the zeros of the function. So let me pull up my calculator. Sorry about that. All right, so I am going to first go to y equals. If you aren't already there, go to y equals, and I'm going to type in x squared minus 5x minus 6. That is the function we're going to look at. Now I'm going to go to the graph. You'll notice it does take the shape of a parabola, and it does have two zeros. Now, this one is fairly obvious, and I can see what the zeros are. However, we need to have a strategy in case we can't see them that easily for finding the zeros. So that's what I'm going to show you. What we're going to do is we're going to use the Calculate menu. That's here where you see Trace. So we need to hit Second, Trace. What are we trying to calculate? We are trying to find the zero of the function. So I'm going to select option 2. Now here's where it gets tricky. The calculator needs you to tell it which one to look for first. You cannot find both zeros at once. You can only find one at a time. So it's going to ask you a few questions down here. It's going to ask you for a left bound. That means, how far left do you want me to look? So if I'm trying to find this 0 right here, I need to go a little bit to the left of that. So I'm going to use my left arrow key and arrow over until I'm to the left of this 0. I don't have to be very far to the left of it. I just need to be slightly to the left of this 0. And then I press Enter. That gives the calculator a leftmost point it needs to look. Now it's going to ask me for a right bound. Again, I'm looking for this 0, so I only need to go slightly to the right. I do not have to take my cursor all the way over here. That would actually be too far to the right. I want to just go slightly to the right of where this crosses the axis and press Enter. Then it's going to ask me to take a guess. In other words, it wants me to put my cursor as close as I can to where the 0 is. You don't actually even have to do that. You could just press Enter a third time and it will still work. And it gives us a 0 here at the bottom of the screen. So one of the zeros of this function is at -1, 0. Okay, now, if you would like to find the other 0, you're going to do the same thing on the other side. If you feel ready to do this yourself, you can go ahead, press pause, and then check with me afterwards. or you can follow along with me. Okay, I have to go through the whole process again. So I have to hit second, trace. Again, I'm looking for the 0 of the function, so I'm going to pick 2. Now, again, this time I'm looking for this 0. So I need to tell it how far left do you want me to look. So I need to get just slightly to the left of that 0. Eventually I'll get there. Aha, here's my cursor. Okay, so if I were right on the 0, I want to go slightly to the left. So I'm going to hit go to the left just slightly, doesn't have to be too far, and I'm going to press enter. Now this is as far left as it's going to look. Now it wants a right bound, so I need to go slightly to the right of that intersection and press enter. Now it asks me to take a guess. So I'm going to get my cursor as close as I can and press enter. And it tells me the other 0 of this function is at 6, 0. So those are the steps for how the calculator can find zeros of a function for you. All right, last thing to think about is, can parabolas have no 0 or only have 1 0? Both of those are possible. See if you press pause and see if you can draw a parabola that has no 0 and then draw a parabola that has 1 0. Okay, a parabola that has no 0. That means it has no, oops, don't have my pen. It has no x-intercepts. No x-intercepts. So it can't cross the x-axis at all. A line will always cross the x-axis because it goes straight. It has to cross it eventually. But a parabola does not. So a parabola like this would not have any x-intercepts. I could also draw one the other way, an upside down parabola. If it starts below the x-axis, it'll never hit it. So these parabolas have no x-intercept. It's also possible for a parabola to only have 1 0. That means it can only have one x-intercept. To have one x-intercept, the vertex would have to be on the x-axis. Something like this, or like this. So if the vertex actually is on the x-axis, it will only have 1. So there are 3 possibilities. It might have no x-intercepts, it might have 1 x-intercept or 1 0, or it might have 2, as we've seen a couple examples of. All right, we will pick up from there in class. Thank you for watching.